Test, test. Cool. Hello, everyone. Hello, hello, hello. As see from the title, we are adding and removing bugs today. Hopefully more removing than adding, but as you can see from the changes not staged for commit, I might have gone a little bit overboard before we got started. So the first thing that we have to do is untangle this mess and figure out which parts of this change are independently committable. I'm hoping this is at least more than one commit, because if it's one commit, I'm going to be very sad. But I know I've got one, fairly independent change in the malloc library, which is I changed the location of some of the data structures. I had a bunch of data structures sitting in stdlib.h that I didn't want there, so I've moved them out of the header so they're not accessible. And we will see if I can get this in independently and it doesn't depend too much on everything else. So I know, unfortunately, we are going to have a dependency here on main, and this might be a real bear because it's trying to make this all one hunk. We may actually need to just do a little bit of unstaging here, and maybe make this change a little bit more slowly. So if we just made a quick test branch, and so to do this, we're gonna add everything on the main branch. And we're just gonna commit this whole thing as no. We're gonna go back to our branch now, where I can say hey, I want stdlib.h and libc malloc, and then we'll see where this fails. Well, this fails because we need to make one small change to main. That this is no longer called global heap. This is now called _global heap footer, and everything else should be relatively fine. It's not relatively fine. We just need to make this change now. And everything else should be fine. Okay, so that's now one change. No, I really don't want to do that. I'm too in the habit of typing git add dot to add everything, but I really can't do that right now because I've got a bunch of stuff sort of spinning around. This presumably includes all of my statics. It does. Yep, we build, we run. Cool. It's good enough. Yeah, actually, no, it's not. double underscore names and some internal functions static should be a boon for the optimizer 2. Okay. So we still have a huge diff with master. And I think maybe we could try to do the Syscall stuff next. Syscall.h and libc syscalls.c and syscall.c. And there, this is also where the generate syscalls diff comes in, and that should be good. That should just build, I expect. I am not correct because of the one other thing that needs this, which is a user program, and I can just check this out as well. Okay. That should build, that should run, it does, perfect. Namespace, remove syscall and from the global namespace, more names. Okay. We've got a whole bunch of printing stuff in there. There's more namespacing changes as well, which is what I would prefer to do first. Yeah, so crt0 libc entry 0.s and libc entry renames the libc entry points. Not get add, get co master. Just renaming, again, more global namespace names to reserved internal private names and making initialized standard library a little bit less huge. I again expect this to just work. It seems to. Is that all of the names that I changed? I think that's all of the names that I changed. Done. The thesis here is anything that's in libc should be an internal or reserved name. That I should only be, I can use whatever names I want inside the kernel because the kernel doesn't ever have to interact with anybody else and should be using application reserved names. But that in libc I should be using names that are not going to collide with users, that I should be responsible with my naming policies. So that's those commits. And now we should be able no, you don't like that. Merge conflict in kernel main, but that's actually fine. This should be a very simple merge conflict. It is a very simple merge conflict. Okay. So that has resolved our need for the branch, I believe. Just because this is now... Okay, there's some stuff that I need to pull out of here, actually, so it doesn't quite remove our need for it. Undo that commit. Most of the rest of this, though, I think, is related to... So include string, this is not good. We just shouldn't do that at all. But the other thing that I was working on was not printing out as much sort of redundantly. Like pick initialized, that's not really that's not interesting or useful information anymore. That was very helpful a very long time ago, but it just really isn't anymore. So I don't want to print it all. And some of it I've just removed entirely. Things like the pick initialized. I don't care. It doesn't matter to me. But a lot of it I've controlled behind a kernel flag. So right now, you see if I build and run this the previous time, is in here somewhere. It was printing all of this initialization information, which is always the same, right? This machine is not changing. It's always got the same memory map. It's always got the same, it's always going to initialize the structures in this order. It's always going to find the same PCI devices. Like, this is just not, it's not useful information for me for right now. So I've just removed all of that, right? I've gotten rid of everything except for the version banner and welcome, which is coming from the shell anyway, or init probably. But I've controlled that behind this grub config option. So if I say boot equals quiet, we get that. If I take that off, or say anything else except boot equals quiet, it's a lot of that information. It's not everything we had before, because of things like the pick. But now it's at least it's giving me the multi-boot information that I care about, it's giving me the memory map information that I care about, and it's giving me the PCI devices. So I can at least get that back quite easily if I want it. So now the only question left is this just good to go already, or do we need to do anything else? So no pick, no pit, the grub config change, just global variables, fine. Significant reordering going on in here, up at the top at least. I want to make sure that this is at least sort of notionally similar to what we were doing before. This has been moved way up, but that's fine. These are just static initializations. Heap init is still, it's not quite first. No. Am I doing VMM twice? Is that what I interpret from this? I may have broken this with my merge commit. I am doing that twice. Heap init should be very close to the top, but IDT should be first because the IDT gives you the ability to see debug traces. I should probably just write this down. Panic backtrace doesn't work. These are the things that I care about happening very early in the boot process. And by the time you've gotten past serial init, nothing really matters anymore. because by the time you've initialized serial, and we have the early heap as well, because you have to do that to get serial, you can allocate memory, you can print. Like we're gooch, right? We're good. We're golden. Sure, we don't have the physical memory management. We don't have multi-boot set up yet, but that's not a big deal. A lot of this needs to be cleaned up. I mean, this could happen first, right? There's sort of no rules. Except that panic with no serial is kind of a hard time, but also if the bootloader isn't multi-boot, are we even going to get that far? Who knows? I mean, we're talking about like some very weird problems. Running the system in a completely unsupported way, or like I'm not really interested in doing a lot of work to be perfect if somebody goes out of their way to do terrible things. That's gotta go. I think this is getting good. It's getting good. I don't know why that's so far over. I think we'll go ahead and take that. All right, and that should be what, 4 changes pushed. We can go ahead and kill branch. We can also kill the reformat branch that I made forever ago, because that is not going anywhere. All right, so I think we are gonna get back to, we might try to do file system stuff, honestly. I know I did a stream on that. I might have honestly not even made it public because it was not a very good stream. Probably like 3 or 4 weeks ago. But we were working on updating the file system to better match reality, where the one I have here is very, I mean, this is the, I think, second attempt at this. I wonder if I can even find the old one. I mean, obviously I could just go back to like something really, really ancient. Initial VFS and read write. Didn't even have a file system at that point. It was just a global table. But that's not relevant to what we're talking about here. My current file system, it leaves some stuff to be desired. A lot of it is just things that I didn't understand when I started writing it. Like I've used the wrong names for a bunch of things and I've put some stuff in the wrong bucket. These functions are not necessarily in the right place. I have used file to refer to the abstract notion of a file, where Unix would call this an inode. I know that now. I didn't know that at the time. So some of what I want to do is just update this, and some of what I want to do is, I hesitate to say rewrite, but I do kind of mean rewrite. I want to be able to support mounting directories in arbitrary places. I want to be able to support more interesting kinds of files, where the system I have right now, the way that I'm doing it is very clunky. And it just makes it very difficult to sort of operate. Lots of excess levels. I'm putting directory entries into basically into the inodes as opposed to into a different layer. So I did a bunch of reading on like how other people do this, how Linux does this, for example, and I come up with something that I think is a lot better, which I sort of prototyped into something that, hey, I can make a directory tree and I can resolve paths out of that. And so this is, I mean, this is not everything you need, but I think it's a lot better than what I have right now. So I think we're going to try to use it. And that's a good point. Then the first thing that I wanted to do with that is this, these string copies, which I believe I already added to kernel string. I added one of them. I should just add the other one so that I don't forget about it. CNC copy stir CC copy, and then go ahead and commit that. Nope, that's not going to be right. No, I don't want to make, well, I think we'll just, I never know what to do with this, right? I've got like a little tiny white space change. Do I make a separate commit? Honestly, the correct answer is probably just don't make that change at all. Make it if I'm going to update that file later. Diff is what I want. I mean, there's no reason that it shouldn't build, but we should make sure. So we've got this fs2 directory here where I'm doing a lot of the thinking this out. And I would really love to be able well, what we should do probably is just like start writing the syscalls and see what happens, which I have some of. Honestly, we should probably just copy snippets files. Got that. Got all of that. We do have to decide if we're going to change our directory entries or not, or if we're just going to use the old ngdirect. Probably just use the old one. Probably. So, what are we going to do with this? Well, if we're writing syscalls, they look a little bit more like, well, I use the word sysret. So we definitely need a fd to struct file function. Open is create. This is flags int mode. But we'll want to create a function for multiplexing that. Okay, that's about what we've already got here. All of this print levels and tree from stuff, this is all user mode code, tree, path. This is all user mode code. This is not code that I'm interested in bringing over. And here we go. So we need, let's make our file, like, I don't know, get file. How are we going to store these? Should probably store them in a well, for now we can just store them in a flat array. That could be like a hash map later or something like that. Depends. It is definitely nice to be able to support. You don't necessarily need to be too worried about sparseness, but you do care about things like somebody opening a bunch of files and then closing, say, all but one of them. Or you can dupe stuff into a high value. So a hash map is a good idea here, I think, but we're just not going to do it right this instant. I'm really trying to just do the sort of stupid simplest thing we can. We don't really want to have these here, though. I do want to make sure we have approximately the right thing in our header files. Entry operations. We haven't found anything that this would be yet. inode, deentry parent, constant our name, flags, potentially. Yeah, well, we have the one flag that's sort of theoretical. What did we have in this? A ref count, children node, so these are all definitely necessary. What did I call this? I called that a file ref count. Yeah, the number of files that have this deentry open. Okay, so we can dump that. I definitely expect in this implementation, I made children a list on the inode, which feels, I guess that's not weird. Hey, Egoist. I'm doing well. I hope you are as well. You are doing well. Hope you are as well. Hope you are too. Maybe that is right. I'm not entirely sure, actually. We'll assume that I had some sense when I wrote this before. And go with that. And if it turns out to be wrong, we can always change it. And the inode is where we get this like dir flag. Mode. Have you been up to doing any interesting programming? Up to anything fun, Egoist? I get the permission bits. Permission bits. that's fun. Shells are that's a good project. Are you writing in C or something higher level? All these new languages. Ah. Rust is fun, as you can tell from the, I bet I have branches in here. Yeah, the 3 different branches where I'm trying to integrate Rust into this kernel and keep, not that it, I keep not coming up with something that I'm happy with. Put approximately that much work into it last time I tried. As we see the integrated Rust branch just sort of chilling out here. But I hear it's really good for doing parsers, so that's probably a really good choice for a shell. There's definitely people that have solved the problem, because there are serious OS projects in Rust looking at things like Redux. The problem I keep having is that every time I want to pick a higher level language, which I've done this with Rust, I've done this with C++, I want to like bolt it on to what I already have so that I don't have to rewrite all of this. I don't want to touch anything in the Arch directory, basically. Everything in there is too arcane, it's too terrifying. So I want to like keep all of that. And it's that like that interrupt layer that I keep getting annoyed by. Like Rust is great if you can actually guarantee the safety of your functions, but when your memory allocator is not and you can't guarantee that it works because it's written in C, it got kind of annoying. I don't know. I'll get there someday, I'm sure. And maybe by, I had some inspiration recently. I was watching, I always get in my head too when I'm writing Rust. I'm like, oh, I gotta abstract and do like a trait or whatever. And I read a whole thing called Learn Rust the Dangerous Way, I think it was called, and it's pitched as like a, hey, you're a C programmer, here's why you should care about Rust. It was a very interesting exploration, because it was, let's take this C program from the benchmarks game, the computer language benchmarks game, it was an n-body simulator, right? This like highly optimized C code that uses SSE instructions, and it's been like manually vectorized, and he translates it 1-to-1 into Rust, right? Like pointers to pointers, everything unsafe, and then goes through in a series of like 5 or 6 blogs and says, okay, cool, so here's where we can take this unsafe thing and replace it with this safe construct. And oh, here, let's take these pointers that are trivial and replace them with references. And look, we lost 0 performance. And we can take this this pointer and replace it with an array, and we lost 0 performance. And then the big really fun one is at the end he's like, and you know, I'm sure the manual vectorization was definitely like, it's definitely really important, manually vectorized, you know, we're definitely not going to win here safely. He rewrites the loop in safe Rust and the compiler auto vectorizes it. It's faster than it was before. It was great. Fantastic read. Do recommend. I could put a link to it. It sounds like you probably have a handle on Rust already, but just in case there's somebody else or somebody comes along after the fact. What am I doing? I'm in FS2. I don't know why I keep building the kernel. So if we're gonna do open, and we definitely have that, and that's fine. We definitely don't want that. We definitely don't want that. We'll deal with that another time. I do like something like this, but it should really go in the other file. It's already in the other file. That's how you know I'm completely dead, because it's literally already there, except for the part that I've got two different versions of this structure. I don't know why there's a whole separate version of the structure here, because that's wrong. Oh gosh. Oh, all of this is wrong. No, we're gonna go ahead and kill literally all of that, because all of that is wrong. Hey, at least I'm starting to get a vision for what wrong looks like, as opposed to just flailing in this directory. So we definitely need these path resolution situations. Which in turn means I need find child, which is unfortunately, I shouldn't put this up here because they are where they are for a reason. Unfortunately, this find child is not entirely correct, because find child actually needs to be different if the so find a child of a directory. In the trivial case, say a ramfs or procfs or something, you always know all of the children, so you can just look through the cache and you just do this and you know the answer. But not every file system is trivial. For example, ext, you don't know until you ask the disk. So this is like this is like the find in cache. But the thing that I think we can do is we should just have a default implementation. Do I not have an inode dot? Oh gosh. So inode needs to have a way to look up a child, and I've got a function here called lookup. And then I think what I should do is I should say like default lookup, default inode. And that definitely needs a name too. Because how are you supposed to look up a child if you don't know its... Well, you do know its name. Yeah. So, and then the default is... The way I did this before was like freaky recursive. The way you find a child is you find the child. No, it was add child. Create a new subfile that's like freaky recursive, because add child calls find child to find. Yeah, this is why it's freaky recursive, because add child, right, create a new file in a directory. Sure, we've got this null case, but let's ignore that for a second. What does add child do? Add child calls find child and returns the child with a increment to the ref count. What? Where does it actually get created? And the answer is it's like mutual recursive with find child right now. I don't know if this is terrible, but add child, if you give it in the normal case, right, you're yeah. In the normal case, you call add child with an inode, right? You're trying to add this inode with this name to this directory. And inode is not null, so it just says find it. If it found it, good. Where does it get created? Well, find child, which actually calls add child, mutual recursion. Add child calls find child calls add child, but it passes the null, so it hits this case. It creates an entry that has no inode, returns that entry, ends up back here, puts the inode in that entry, because, and the reason I chose to do it this way is that add child has to know if the child already existed, so it has to implement the find logic, and find has to be able to add a cache entry for null, so they each have to do the other's work. So I made them recursive because I really wanted this to be so confusing that I'm sitting here for like 5 minutes staring at it while I try to figure out how to explain it, which is maybe not a great sign, but it's the world we live in. So I think yeah. I'm trying to figure out how this fits into like an inode can have lookup logic that's different. Because all of this is still the same. This is just like the directory cache working. This is not something that needs to change. The only thing that would change if I was, say, going out and looking up an ext, well, I would need something here, presumably, that would like figure out if there was something else to do. I probably shouldn't worry too much about this now because I don't have an ext, like a disk file system to worry about. I should probably just do this the way that I sort of expect it to be needed to be done and then figure it out later. So if I was going to write open, well, if let's first figure out if it exists, right? Dentry is resolve path from working directory. We'll figure that out. Don't have that right now. Actually, that's probably just going to be running red cwd2. Actually, that's probably not too long. Being a little aggressive with my line splitting there. If the dentry exists and well, sorry, if it does not exist and we are not doing create, is it noent? What are the errors? Path name refers to a special device and it doesn't exist. Enoent, ocreate is not set and the name file does not exist. Perfect. So now there's like two cases. If create, else. We know in this case that the file does not exist, so that's basically we are our dentry already. Right? We just need like a we have our dentry. We just need a new inode, which would come from the file system, presumably. Yeah. Ops new inode. And then like add child. No, not even add child. Like that's just it, right? Because that's already in the correct space in the directory structure. It's already got the right name because that's how resolve path works in this new system, which is beautiful. Yeah, that should be like it. And then the only thing that's not done here is the file system needs to be populated, which we are not currently doing. So obviously still have to write that function, but that should be like, well, that's not quite it, but should be something like this. So we're just calling add file for now will be the function that takes a file pointer and adds it to the file descriptor list. That's probably not a great name. We could rename it. If the dentry, so if we're not doing ocreate, something like that. I presume. Am I using UEFI or Legacy Bootloader? I am currently using Legacy Bootloader, but I could support either, because I am just using the Grub bootloader, right? I'm using a freely available bootloader, but it's like a, well-developed bootloader. It's the same bootloader that Linux uses in most cases. So it can run on essentially anything, and then it just exposes a boot protocol to me. So like this is my grub config to boot the kernel. I use multi-boot as my boot initialization API, but I theoretically should boot on any system, UEFI or not, that supports grub. I don't do a lot of UEFI testing just because booting UEFI machines on QEMU is really annoying. Like emulating and virtualizing them is much more annoying than legacy BIOS. But I mean, the CPU list that you get, not CPU, that's not what I wanted. QEMU supports just about everything as far as CPUs are concerned, but the default machine is from 1996. Standard, quote unquote, standard PC, i440FX, PIIX. I have no idea what those mean. 1996. So that's just sort of a sense of like the era that we're talking about right now. It should be pretty portable though to newer PCs. Yeah, I think that's... Yeah, it's something like that. Obviously, it does it to boot this computer, right? The one that I'm... Not the one that I'm typing on, but the machine that I'm programming on is a Linux computer that boots with grub on a UEFI system, so... I don't know how that works, but it does. Magic. This should be fine. So I have to abstract this a little bit more. This definitely needs that. Getting dangerously close to 80 columns there. Might have to do a very annoying amount of wrapping. So to do openat, we're going to want to do some abstraction just because they are almost identical. Literally the only difference is going to be open is of running thread CWD 2. Path flags mode. And this is going to be do open to of file path flags mode. It's just those are almost identical. What happens if the path doesn't exist? That's actually an interesting question for the manual page. If you try to open something, like if I tried to cat ABC, like that's just a completely invalid path. We end up with no such file or directory, which might be the same enoen. But I'm not entirely sure that that's the same. Yeah, okay. So ocreate is not set and the name file does not exist. That's enoent. But enoent could also be a directory component in path name does not exist or is a dangling symbolic link. Or it refers to a non-existent directory. Or it's a... No, that's enoent. Okay. So since we're doing the exact same thing, though, and we have to check this anyway, just put that into that conditional. So we need, we have get file, add file, inode to file, which we're calling new file, and then file system : new inode, essentially. Cool. That's our to-do list getting bigger. Directory entries should look somewhat similar. Somewhat similar. So in the here I have been doing, well, what did I do for get dense? For each I know children, yeah. Which I think is more or less correct. This is the same problem I had before, right? The like, this is not going to work with not going to work with like ext, but I'm not really interested in solving that problem right at this instant, because I'd have to slurp in the directory contents at this point if I was going to list them all out. Inode file, inode flags, directory inode children. This should probably not be called buffer. What does that look like? Durant type, mode, and name. Where does that type and mode come from? Standard IO. That's creative of me to put these in. Standard IO. This is also wrong. Well, it's not wrong. It's not right, though. Which is to the sticky bit is ISVTX. Don't ask me why the sticky bit is ISVTX. I cannot figure that one out. Maybe inode would tell us. It has a reference there. ISVTX. The sticky bit. ISVTX. Admittedly, I'm using the wrong names for these anyway. Honestly, I should do them right, though. Well, mine are better, but I can do these too. Now I've got all kinds of extra spaces. Definitely not interested in C below. Cool. So that at least gets me the official names of these things. And that we can honestly just, oh, well that, so these constants, in turn, I think this tells me they should be in file control because this is referencing them without talking about including any other headers. So we may want to just move that. Standard IO. That leaves a lot of questions open, though. Specifically, it leaves questions open about what do you do with seek modes and file types. Do you put those in? This is definitely not supposed to be defined here. This is definitely a Lua specific thing. I definitely defined that for Lua, and it's definitely not necessary. Let's see if I just like screwed something. No, you actually want... Sorry, now I'm off the rails. But I don't think that's a real constant. Nope, it's a real... Unlike every other constant in the entire universe, it's real. Capital L underscore. All right, I'll put it back. No, we'll just leave the comment there. It's probably best that way. Let's make sure we can build this stuff too. Type all the files whose name is star.c. Ah. Very not going to work. But we knew that was going to happen. Yes. So what did we wanted to... Actually, I know what I'm going to do. So everything in FS2, all of these names are sort of unacceptable, right? Because, like, I can't call this struct file. I already have a struct file. But we know that everything in FS2 is including fs2/types.h. So we can do some real, true evil. That actually might be the only thing that I need to rename. File operations. So that when they get mixed in with the rest of the kernel, it doesn't mess anything up. Yes, it's super not going to build right now. I know, I get it. Because why would it build? I feel like oh yes, I was going to add in some metadata. So that's very helpful there, but it also means that I can't include that directory here. I can't include any of those things here because they'll be renamed. So I might have to do that manually. So CWD2, we know we needed that. We know we needed we know was that it? Is that it so far? Yeah, get file. We're not going to worry about that yet. Right, we did need to, that was what we were going to do. We were going to add it to the processes table. Number of fd2s struct fs2 file star fs2 files. Ew. New thread fs2 files equals which of course means that all of these things need to be included. Which we have no way to do right now. Come on. What else? The entry. Oh, of course, nothing is even including that. I'm sitting here saying confidently that everything is including that. It's not. H, please. Okay. Inode types, file the entry, head 3. Types needs to be pragma once. And then what we can do is we can make an include ng fs. No, we're going to use the same header because I really don't want to have to duplicate all the headers in the includes. And here we're going to say include file inode file system and dentry. They all include types.h, so that's fine. Okay. Okay, file flags is, but I'm going to presume that file flags it's not the same. It's not even the same file. Okay, yeah, we need to rename that. Yeah, that's not even. Okay. Why are we returning from non-void functions in a header? That's creative. Oh, good. Yeah, let's just have headers, functions in our headers. Like it. And now every single compilation unit is dying on empty structs. Okay, redefinition of those things. We really shouldn't have to worry about. Where are they in FCNTL? They're in open flags, which I think we're just gonna call okay. FS2 file need not worry too much about that. NT file control. Threads don't get FS2 files. Those are processes. FS2 in new process. And FD2s is 8. Did I really name it that badly? I really did. I really named it NFD2s and FS2 files. Oh well. Okay, are we at least back to building? Yeah, now we're building FS2 tempfs, which we know because we haven't even looked at that today. There's all sorts of stuff going on in here, I'm sure. I'm just gonna tell it not to build that. We should at least be focused on the things that we care about. Which are not really in here. Yeah, we've already solved this problem. Go away. Make empty file. We need something a little bit like this. That's a very interesting question. Syscall, we started working on creating things. Permissions checking is important. Ditto here. And we no longer have a dir. ng durant not found because it's not called that. It's called durant.h. All right. Sometimes I wish I actually bothered to get this set up in the editor. Not always, but sometimes. I wonder if Vim will actually... Yeah, the quick fix list is great, but you've given me an empty buffer. Very helpful. Why is the file empty now? I guess it's expecting something different. Q all. Either it's like reopening or I don't know. Whatever. Not worth crying over spilled. I mean, there's so much wrong here already. So for example, this needs to at least be prototyped above. There's our get file. Let's go ahead and write this. FD2s. No, I did not call it FD2s. I called it FS2 files. FS2 files. For no, I should really get a, I should not do this with a cursor. Ah. Here's what we can definitely do. We may not be able to do it in the header, but we can definitely do this here, because that will not impact anything else. It's not there, good. Okay. And then here, we have no other instance of that, and it's fine. So struct file just means fs2 file here, as it should. Very reasonable. Okay. So I is 0, 0. FD2s if just expanding the array and adding it in if we already have too many. Again, this should really be a hash map or something, but I don't have one that's like handy enough that I'm gonna do it right this instant. I'm writing one, but that's coming later. No struct. that's super wrong. Theoretically, nothing has put something in there. This is really, really, really terrible, and I would never use it except just to see if it works. And that's as far as we're going with this. And then return previous max. Terrible, terrible, terrible. Do not, never. Bad, 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 bad. We needed to use resolve path from, so we need to put it up here. Okay, so create. With an inode. So this is just add child, right? Well, not really. No, this is... I think it might be that simple. At least as it has been specified by me. It might be that simple. All right, inode to file. But we wanted this to take a file. So this will actually be related to this. What do we do with that? Dentry inode and flags. And flags. Okay. Very reasonable. Very reasonable. I don't know why these are down here. They should probably be up with these functions. Get file, add file, new file, create file. No, it's specified as create. We're going to leave it there. We can always refactor the names later. So, new file from an inode. And flags. Files get, this should not be an inode. This should be, ooh, that's kind of an interesting dependency. Files. Well, it's not an interesting dependency because we have the dentry right there. Files need a dentry so that they can get things like names. So this actually is not an inode, this is a dentry. File inode is dentry, inode file dentry is dentry. Do we have anything else in the current? No, just flags and an offset. Well, then we're going to look in the current implementation of the file system for open file, which is what I used to call this. And it's still pretty simple. I think we're gonna actually put that outside. So yeah, the flags, which is gonna be things like readable and writable, offset, and then we'll just give it a void pointer basically. So do we need to validate that? I don't know. And then we can actually go to file.h and make that. File flags is flags. File operations is ops. That we know how to deal with. File ops is dentry inode file ops. And then just void star extra for anyone else to use. In the case that we had before that we were looking at, that is the proc file system. When you open a proc file, right, when you create the file struct, or as I used to call it, open file, you do all of the templating. So like we go to, so for edification, when I say proc file, I'm referring to, on Linux, the /proc file system, which contains a number of files and directories related to status information about the kernel. So each of these directories, there's one directory for each process on the system over here. And then there's a number of files that are sort of related to things that are not directly related to processes. So for example, if we were to look at proc interrupts, we can see the CPUs in the machine and the times that they are being interrupted for various different things, like ATA PIIX is going to be a disk responding, right? A disk saying, hi, I have data for you, ATA like SATA. So CPU 3 is apparently the one getting the ATA interrupts on interrupt IRQ number 15, and it's gotten 350,000 of them since I restarted. So this is all actually, this is templated, this is printed by the kernel into this file notionally, and it changes every time I print it because this is real-time data. And the way that I handle this, so that was Linux, this is me. The way that I handle this is when you open the file, I call the associated function, in this case proc threads, which then uses essentially sprintf, right? It's printing into a buffer to build up the full thing, and then you can read that out. It's all in a buffer. You can then read that out, you know, 1 byte at a time if you really want to. Yeah. So if we stash and build the system, right, there's a number of things in /proc. Mem is giving information about memory in use. In use are about 1 megabyte. Available are about 19 megabytes. Mods is going to be empty because there are no modules loaded right now. Syscalls, this is all of the syscalls in the Nightingale system, in my system. Their names, their addresses, the number of times they've been called. So this is, and then we were just looking at proc threads, so let's, I guess, just look at that to close the loop. This is the, whoops. Break everything. This is the result of that sprintf in a loop that I was showing earlier. That it, for each thread, it gets this data and prints it out. So that's something that you would need in struct file, is the ability to handle that. And I think just having a void pointer and having it manage its own data is going to be fine, hopefully. So, and we don't need to touch anything here because this is for the, or do we? Is this only for the trivial case? That's the question. Or does this get used in the complicated cases? I'm not sure. I think I actually need to think about that a little bit longer. Not that I want to get bogged down in the, as I keep saying, I don't want to get bogged down in what if I need to do X later. But I'm also running low on brain power, so yeah, I think I'm gonna wrap this up here for the moment. I think we've done a lot of really good, you know, this is really, really good work as far as like having these things specified out. So I think it's time to let this simmer in the brain for a bit, and we'll come back and do some more of this later. Cool. Well, I hope everybody has a good rest of their days, and I will see you around.